Chapter 3 of Class 9 Physics, which is usually titled Force and Laws of Motion. This chapter lays the foundation for understanding the relationship between forces and the motion of objects. I'll explain the concepts in detail with examples. 1. Force. A force is a push or pull on an object that can cause it to accelerate, decelerate, or change its shape. It is a vector quantity, meaning it has both magnitude and direction. 1. Units of force. The SI unit of force is the Newton, N. 1 Newton, N, equals 1 kilogram m/s squared, meaning the force required to accelerate a 1 kilogram object by 1 meter per second squared. 2. Example, if you push a box on the ground, the force you exert on the box is responsible for moving it. 2. The force you apply determines how quickly it moves or changes its direction. 2. Types of force. There are two main types of forces: contact forces, forces that require physical contact between two objects. 1. Examples: frictional force, the force that resists the motion of two surfaces sliding over each other. Tension force, the force exerted by a rope, string, or cable when it is pulled taut. Normal force, the force exerted by a surface that supports the weight of an object resting on it, perpendicular to the surface. Non-contact forces, forces that do not require physical contact between objects. 1. Examples: gravitational force, the force that attracts objects towards the center of the Earth or any other planet. Electrostatic force, the force between charged objects. Magnetic force, the force between magnetic poles or moving charges. 3. Inertia. Inertia is the property of an object to resist changes in its state of rest or motion. The more mass an object has, the more inertia it possesses. 1. Example: a heavy truck will take more time to stop if you apply the brakes, compared to a lighter car, because the truck has more inertia. 4. Newton's first law of motion. Newton's first law of motion states, this law is often referred to as the law of inertia. Example: when you're driving a car and suddenly stop, your body continues moving forward. This is because of inertia. Your body wants to keep moving, even though the car has stopped. Real-life application: seat belts in cars prevent passengers from continuing their motion when the car suddenly stops. They provide the necessary force to change the passenger's state of motion. 5. Newton's second law of motion. Newton's second law of motion states: 1. Formula: F equals ma. 2. Where F equals force in newtons, N, m equals mass in kilograms, kg, a equals acceleration in meters per second squared, m/s squared. This law explains how the velocity of an object changes when a force is applied to it. The greater the mass of an object, the less it accelerates for a given force. 1. Example: if a car of mass 1000 kilograms experiences a force of 5000 n, the acceleration of the car will accelerate at a rate of 5 meters per second squared. 6. Newton's third law of motion. Newton's third law of motion states, this law explains how forces always come in pairs. If one object exerts a force on another, the second object exerts an equal and opposite force on the first. Example 1. When you jump off a boat, the boat moves backward. Your action, pushing on the boat, has an equal and opposite reaction: the boat moves backward. Example 2. When you walk, your foot exerts a force on the ground, and the ground exerts an equal and opposite force that pushes you forward. 7. Momentum. Momentum is the product of an object's mass and velocity, and it is a vector quantity. Formula: 1. Momentum, P equals mv, where 1. m equals mass of the object. 2. v equals velocity of the object. Example: a small car moving at 10 meters per second may have less momentum than a truck moving at 5 meters per second, even if the car is moving faster, because the truck has more mass. Impulse and change in momentum. The change in momentum is caused by a force applied over a period of time, called impulse. Impulse formula. 1. J equals F delta t, where J is impulse, F is the force, and delta t is the time interval. Example: if a cricket player uses his bat to change the velocity of the ball, the force applied by the bat over the time the ball is in contact with the bat results in a change in the ball's momentum. 8. Law of conservation of momentum. This law states: 1. Example: when two ice skaters push off each other, they both move in opposite directions. 1. If one skater moves forward, the other moves backward in such a way that the total momentum of the system remains zero, if they were initially at rest. 9. Applications of Newton's laws. Newton's laws of motion are fundamental to understanding everyday phenomena. Here are some common applications. Seat belts in cars. Seat belts are used to prevent the inertia of the body from causing injury during a sudden stop, first law. Rocket launch. The rocket exerts a downward force by expelling gas, and in reaction, the rocket moves upward, third law. Sports. In sports like football, players push against the ground to move forward, and the ground pushes them forward with an equal and opposite force, third law. Walking. When you walk, your foot pushes backward on the ground, and the ground pushes you forward, third law. 10. Friction. Friction is the force that opposes the relative motion between two surfaces in contact. Types of friction. 1. Static friction, the frictional force that prevents two objects from sliding past each other. 1. It must be overcome to start the motion. 2. Kinetic friction, the frictional force that opposes the motion of two objects that are sliding past each other. 3. Rolling friction, the frictional force that resists the motion of an object rolling over a surface. Example: when you try to push a heavy box across the floor, static friction resists the initial motion. Once the box starts moving, kinetic friction takes over. Summary. 1. Force causes a change in motion. 1. It is a vector quantity and has both magnitude and direction. 2. Newton's first law, inertia, explains that objects resist changes in their motion. 3. Newton's second law shows the relationship between force, mass, and acceleration, F equals ma. 4. Newton's third law tells us that for every action, there is an equal and opposite reaction. 5. Momentum is mass times velocity, and it is conserved in an isolated system. 6. Friction resists the motion of objects and comes in various types. This chapter is crucial for understanding how forces influence motion and how we can predict and describe the behavior of objects under different conditions. If you have any further questions or need more examples, feel free to ask.